Okay, let's pick up the finishing of chapter 2. And we just did a minimization example using the graphical method. So let's pick up and use one using Excel, the computer solution method. Let's refer to the textbook. And there's an M&D chemical company scenario on pages 54 and 55. And I have the template posted on Canvas. It's given there, Chapter 2, M&D problem template, and it's very straightforward and simple. Once I give you an Excel template, or you develop one, but I'm not going to make you develop them for this course, I will give them to you. Because if you develop them and I had you tested on that, you would probably have, every one of you would have a different format, different template look, feel, and so on and so forth. So I'm more interested in your utility of the models that are being made available to you, and so I will give you that. So once I give you that, I'm going to pull on screen here. This is what it's going to look like. And we're given data that there is two types of chemical products, and how much time it takes to produce them, and how much the production costs are. There are some minimum requirements. There are minimum total production quantities. There are product A minimums within that. And there is a constraint with regard to how many hours of time our production time, processing time is available. So once the template is set up like this, executing is very simple as usual. Select the Data tab, run Solver. Solver parameters will automatically pop up. In this case, just double check to make sure it is set up as a min problem. And in this case, it is. It's a minimized total cost problem. And that's what's expressed in the language too. So once you verify that that's done right, you don't want to change any of these other settings. We'll run solve here. We get an answer. We're going to get this pop-up box. We will select OK here in order to retain those answers in the background. Next week in Chapter 3, we're going to get into sensitivity analysis. We're not going to do that yet today. We select OK. And in this case, the optimal solution is producing 250 gallons of product A and 100 gallons of product B at a total cost of $800. That is our optimal solution. Now, coming back to some questions I might give you. If I were to give you this template on a quiz, I might ask you, what's the objective function for this problem? Is it max or min? What are the decision variables and so on? So in this case, let's answer some of those simpler questions. Is this max or min? Well, just taking a look at the template itself, you can see that I've expressed here minimize total cost. Therefore, you should recognize that this is a minimization problem. Of course, also the language that's used in the setup would tell you that it's a minimization problem. Second question, what are the decision variables? In this case, that's clearly labeled. Decision variables about product A, about product B, and how many gallons to produce. Now, third question, what are the coefficients of the respective decision variables? These are given here. These are part of the setup. You'd have to have read the language in the problem description to know that what we're concerned with is, in this case, processing time and also production cost. And production cost in this case is 2, production cost is 3, and for product B, and therefore those are the coefficients in the objective expression. So in this case, we would note that the objective function would be expressed as min 2 times product A plus 3 times product B. Okay, so a couple of other things to walk through with you. All right, in terms of Chapter 2 review, I'm going to open test number 2 in a week, Monday, June 19th, and I'll close it 5 days later, 12 midnight. There are going to be 10 questions, all multiple choice. 5 or 6 of them, I haven't finalized it yet, 5 or 6 will be definitional. So that means either 4 or 5. The balance will be problem solving, where you'll have to choose the right answer. You will have to do a graphical solution. There are going to be cases where I'm going to give you an objective function with constraints, and I'm not going to give you an Excel template to go along with that. If you're really savvy, you might be able to use Excel and set it up yourself. And I'm not expecting you to be able to do that, but you may then in turn have to do a graphical solution. And I'll note that you're probably going to have to do a graphical solution. Because that's more difficult, more time, it's going to be worth more points. If for examples where I'm going to give you an Excel solution, probably only one, maybe two, the templates will be provided on Canvas. And as we just walked through an example, you can see that it's very, very easy once the templates are established. And I'm recommending that you review the practice problems that I've given you already. They're populated, the answers, in the week 2 module. And something else to remember also, that week 2 has an assignment problem. Assignment problem number 1, it's in week 2 module, and that is due week after next. All right, something else that I want you to be reminded of with regard to team project planning. This graphic is taken right from the syllabus. It's the guidance for a team project that I want you to work in pairs. It's going to be 10% of your total course grade. It's not going to be due until the end of our semester in August, but I want to get you started with being paired in your teams soon. So by a week from today, on Monday, the 19th of June, if you want to be teamed with a specific person, let me know. Send me an email, send me a message through Canvas, whatever you wish. Send me a text message. If I don't have some feedback to you by that midnight on Monday, I'll begin to assign pairs of students randomly for this assignment. And then this way, you'll have the opportunity to consider what it is you might want to do. We're doing linear programming techniques right now, and we're still on chapter 2. We'll be doing these other techniques. And in simple terms, think of this project and this assignment as if you were creating a problem for the textbook, and you're going to solve that problem. You're going to present that problem. You're going to show how you developed it, so on and so forth. You won't necessarily obviously present it in person. I'm not expecting you to do any recording. I'm just expecting you to deliver a file. I'll go into a little more detail as we get closer to delivery, and I'll explain that in July. All right, so that's the end of week 3. Thank you for your attention. Have a good week. Finish up chapter 2. Get ready for the next test. Thank you. Bye.